So what questions do you have at this point in time?
For me, the Anova thing, especially when I was working on module 6, it's been math, and they're like other different things we're learning and stuff. They are all similar. They're all different.
Mm-hmm, mm-hmm.
You know, so it's just kind of, if you can briefly, like I know, for example, when specifically where you use it. I went through the thing, and then with the test and stuff, with the information from the test, it's just being a little more specific on like when will you use Anova, and just briefly talk about it. I don't know if you guys talked about it on the Thursday meeting, but yeah.
Okay, yeah, I'll just kind of take notes. So give a kind of an overview again. When do we use Anova?
Mm-hmm.
Okay, I can do that for sure. So that will be one. What other questions do you guys have? I think that would be a great one to start with. Are there any other questions that you have at this point in time? Hey, William.
Hello.
Do you have any questions already in mind?
I noticed that the assessment 2 had a quiz. Is that a graded quiz for 7, or what's that about? Is that for next?
The assessment 2, that will be the assessment 2 will be similar to what you did for the assessment 1.
And we'll have a gap from Thursday to Monday.
Yeah, like 2 days to do that, and it's going to be about Anova, so one-way and two-way Anova. So two-way Anova is what we start this week. One-way Anova is what we did last week, and next week, the whole week is going to be just revising. We'll put some more exercises up, and it goes really comfortable using it in Anova.
Okay, perfect. And we're gonna have like an SPS worksheet that we can work ahead of time, and then just either answers the input into the multiple choice test, or is it different?
Yeah, exactly. That's how it's going to be.
Okay, perfect.
Cool. Any other questions? No other questions? Okay, let me. So what do you guys say? When do we use the Anova? That was one of the questions.
When you have 2 or more variables.
When you have 2 or more variables, okay, yes. All right, I'm gonna kind of probe you a little bit, okay? So let's say I have a variable gender and I have a variable reading test. So I have gender is boys and girls, reading test is, let's say, from 0 to 100. Right, I have 2 variables. Would I use?
I believe not. I believe it would have to be with gender. So it'd be like comparing the test between the boys and then comparing the test between the girls.
Yeah. Right. So if we have the gender, we have 2 levels, right? We have boys and girls. And if we compare the reading tests scores, we would compare the score for boys and the score for girls. Right? So we have 2 groups. We have 2 variables, but we also have 2 groups. We could do that with a independent t-test, right? Because we have just 2 averages. And we can also do it with an Anova. However, the Anova we use when we have more than 2 groups, right? And that's maybe what you meant when you said more than 2 variables. Like one variable is the grouping factor, right? Let's say gender could be boys and girls. And let's say we add another one. It's maybe people that didn't want to disclose their gender. Now we have 3 groups, right? So now we can do a independent samples t-test. We're doing in Anova where we can test all 3 groups with each other at once. And then we, let me just back up a little bit. We do it when we have 2 or more groups. Or ideally, we do it when we have more than 2 groups. But if you have 2 groups, you can have it. You have a choice: either the independent t-test or the Anova.
Okay.
But I'm going to tell you why, or maybe one of you would like to say, why should you, when you have only 2 groups, why would you rather do a t-test? No idea? So the reason why you should rather do a t-test is because it's going to be straightforward. Right away, you're going to compare the 2 means, right? If you do an Anova, first we test if there's a difference between groups. And once that is significant, if we know there is a difference somewhere, then we try to find out where exactly is that difference coming from. So let me go. I'm going to open up the slides of module 6. And here is this overview. I'm going to share my screen with you guys. Okay, can you guys see this? All right, cool, thank you. All right, so if you think about, we started over here with the descriptive statistics, and now we're over in the inferential, right? Inferential means we are, from a sample, we're inferring to the population, right? So now we are in this area here. This is the compare the means area, right? When we had only 1 mean, we did the 1 sample t-test, right? That was, we would take an average of a group and compare it with norms, for example, right? You could say the state test is 50 points from 0 to 100, right? It's 50 points. Your class scored 55 points. Is your class significantly better than the state, right? You could answer a question like that. Then if you have 2 groups, let's say you have a section 1 and section 2, right? Section 1 scored 55 points, section 2 scored 58 points. Now you could say, hey, is one of my sections higher than the other, right? Different kids in both sections, I can compare those 2. And when we did the pair t-test, we said same group of kids. So we could say in the beginning of the year, section 1, and now we're in mid-semester, we can compare and see, give them a test, and we could see, did they increase in reading over the last 8 weeks during the semester, right? That will be the pair t-test. Still only 2 means. And now, when we have more than 2 groups, then we use an Anova. Right, and you see here a F and a P, and that basically is that area for comparing the means. The rest here, what you see over here, will be later this semester. We will talk about this in this course, but right now we're going to finish up this whole idea of comparing means with each other. And let me skip to the process. Now, let me show you. Let's look at this one. Can you guys see the entire slide? Yeah, okay, great. Right, so here you see the idea behind Anova is this. We say, okay, let's say these are 3 different classes here, right? You have a mean, and then you have a variation for each class. A mean and a variation, a mean and a variation, right? We look at this graph here. Would you say that 4th, 5th, and 6th are different from each other? Right? There's no overlap. So you could say, yeah, they're probably different, right? Now, there is a difference at some point in time where we say they're too close, right? For example, P and C, those 2 might be too close, right? But we're pretty sure that C and E are different from each other, right? So the ANOVA compares the variation within each of these groups to the variation between these groups, right? So that's the whole goal of the ANOVA, is to estimate variation within group that is normal, right? That we don't expect the classes to be exactly the same, right? If one of your sections has a 55 in a reading test and the other section has a 56, right? By now, you know that there is some variation with each estimate. So although 56 is higher than 55, you might say, well, I'm not 100% sure that they're actually different from each other, right? They're quite close. Now, when, let's say it's 55 to 57, or 55 to 58, 55 to 59, 55 to 60, 55 to 61, you see how at some point in time you're like, okay, now there's a big difference, right? Now I'm pretty sure they are different from each other. So statistics is all about figuring out the probability of them actually being different. And if you imagine that each, I'm kind of doing this here, that each distribution, if they're wide, it's hard for us to tell if the difference is really due to actual difference or just due to noise, right? And we would say the noise is that variation. So that's why we do this F-test. The F-test compares the variation between the groups. That's this here, between these groups. And then we compare it to the variation within the groups. This here. Right? So the variation between groups has to be bigger than within groups. And if that is the case, then we get a significant F ratio here. And if you look at the videos, I go through this whole step by step, so that should really explain it. But the F ratio is basically the between mean squares of error divided by the mean squares of error within, that F ratio. And if they're the same, the F is 1, right? Let's say if this is 10 and this is 10, 10 by 10 is 1, right? Or if it's 5 and this is 5, 5 divided by 5, it's 1, right? So you get the idea. And now what the Anova does is we're just trying to figure out, okay, based on how many groups you have and how many people are in each group, there's a probability for this F value to be occurring, right? There's a certain probability. And now we're using the whole idea that we developed in the hypothesis testing, right? We said if it's a lower than 5% probability of this F value occurring, then we conclude that the between variation is bigger than within. And then we just know that there is a difference somewhere between the groups, but we don't know exactly where yet, okay? And then when we don't know where yet, sorry. Then we go to the next step where we do the post hoc, where we compare the different means. And you'll see there is a special area for that in the module as well. So, right, for example, for this example here, we'd have section 1, 2, 3, 4. When we did the ANOVA, we would get a significant F-test, which would tell us the ANOVA is statistically significant and would tell us somewhere there's a significant difference. We don't know that yet where. But then in the second phase, we would actually go and compare. We compare 1 and 4, 1 and 2, 1 and 3. And then we compare 2 and 4, 2 and 3, and we compare 3 and 4. So we do then we do those pairwise tests, which also are called the post hoc tests, right? And then you can say this, you can do this move, right? The Duran and Anova, yes. All right, what questions do you have? Or, you know, sometimes some things clarify a bit, while others things get a bit more confusing. What did I say that was more confusing?
Can you talk about the F ratio again? You breezed through that part a little fast for me.
Okay.
Thank you.
No problem. So let me see here. I want to make sure I show that as well. You know, I used to have a teacher that always said, "Oh, it's logical and it's so trivial and whatnot." I try not to say that, but it's really, but once you see it step by step, it's pretty straightforward. But I need to show it in a different way. I'm gonna show you. You'll see you can look at the video as well on the module, but I'll show you I need to show you the calculation in Excel. So if you want to look at this again, it's called calculation one-way ANOVA in Excel, and that way you know exactly where those numbers are coming from. Okay, so now let me see. Because again, once you know where the numbers are coming from, it should seem logical. Okay, so in this example, can you guys see my Excel spreadsheet? Okay, so I'm going to go really step by step, right? We have here the person. We have 20 people, right? That's person. This row here is person 1, person 2, person 3, person 4, etc. Kind of like what you guys typed in when you filled out the questionnaire, right? The survey, you kind of typed these data in. What we have here is that's the only data that we have. The rest we calculated. We know the person 1 is in group 1, and in the stats quiz score, that person scored 14. Now we have the first 5 people are in group 1, the second 5 people are in group 2, 5 people in group 3, and 5 people in group 4. They all have a test score, right? But they participate in different instructional methods, right? Some was just face-to-face, some was online, some was independent learning, etc. Right, now our question is, at the end of the year, when they have the stats quiz score, is there a difference between these groups or not? Okay, that's how we start. Now, the first question is to calculate the within variation for each group. Right? So if we look at group 1, we calculate the average of this group 1, which is 13.8. And now each member of the group 1 gets that value, 13.8. Then we calculate the difference to the mean, right? So the person 1 in group 1 had 14, group mean was 13.8. So that person was 0.2 points above the group mean. Okay. And then we square this, which gives us the 0.04. And if you notice, this is what we used to do to calculate a standard deviation. Okay. Now we do that for each group person in group 1, right? Notice that this person here, the person that had 13 is actually, the group mean is 13.8, that person is actually negative 0.8. So this person is actually below the mean, okay? Now we square 0.8, minus 0.8 squared is positive or plus 0.64, right? So that's the squaring part, gives us only positive values in this column. Now for the next group, we're going to change the group mean to 13.2 because that's the mean of group 2. The mean of group 3 is 11.2 and the mean of group 4 is 14.6. Right? So we did, for each group, we calculated how far away are the group members from the average of the group. That's this here. And then we did the sum of squares within is adding up all these, right? So we squared the differences and then we summed them up. So that's sums of squares within. Okay, now this here is important, right? We're calculating the Anova summary table, right? And when you look at within groups, the sum of squares, that's what we're going to plug in over here. That's within the group. Let me go back really quick. So now what we did, I'm going to look up I'll show you guys on a graph here, visual. All right, we calculated the variation within each group. That's what we calculated, sums within. And now we're going back, and now we're going to calculate the sum between. So now we're not interested within each group anymore, right? We are interested in overall. So now we go from the grand mean, that's the overall average, and we look at how far away is each group from this grand mean. So 13.8 minus 13.2 is 0.6, squared is 0.36. And for each of these group members, we get the same value. Okay, because they're okay. Person 2 is in group 1, so group 1 had the average of 3.8. The grand mean still is 3.2. The difference is 0.6, and the squared is 0.36. Okay, so we did this for each one of the group 1. Now we go to group 2. Oh, group 2 actually, the group mean is exactly at the grand mean, right? So they have 13.2 minus 13.2. They have a 0 difference. 0 squared is also 0. So they get all this value. Right? Then we go to group 3, which is 11.2. It's 2 points below the mean, right? So it's negative 2. Squared gives you the 4. We do that for the other group. And now the last group is 14.6 minus 13.2. It's actually 1.4 points above the grand mean. And that squared is 1.96. We do that also for each of these group members. And now, to get the sums of squares between, we just add up all the differences between the groups and the grand mean for each of these people. So the sum of squares between is 31.6. So the sum of squares within is a measure for within variation. Sum of squares between is a measure for between group variation. And we plug that into our table here. Between groups goes in the sum of squares between. Right. So here is now the tricky part. If we just compared sum of squares, that wouldn't really make sense because we do not account for how many groups is there and how many people are there. Okay. It's kind of like if you want to calculate an average and you just add up all the numbers, right? You also have to divide them by the number of numbers that you use to calculate your sum, right? That's where the degree of freedom comes in. All right, we had 4 groups. 4 minus 1 is 3 degrees of freedom. And we had 20 people minus the 4 groups gives you the 16. If you're wondering where do I pull these formulas from, you see here below is the Anova summary table. This is always the same here. So each one-way Anova tries to fill out this table. It could be 100 groups or it could be 3 groups. It's always going to be this. Okay. So now that you have the divider here, we can divide the between group sum of squares, divide by degrees of freedom, gives you 10.53. The within group sum of squares divided by degrees of freedom gives you the 1.475, right? And now remember how we said we're comparing between group variation and within group variation. So Lauren, now finally we are about to answer your question, right? Now we compare these two proportions. Is there more between or is there more within? Right? And the simple way that we do this is the between divided by within. And this tells us how many times more do we have between than within. That's that F ratio. So 10 divided by 1.4 gives us 7.14. So it tells us 7.7 times more variation is between the groups than within the group. And now we have a way, we use those tables to look up the probability of getting such an F value if in reality there's no difference, right? Things can get crazy. You can get large differences just because of chance, because of randomness. And if we look this up, the probability of getting this 7 just by chance is 0.0029. So a very small probability, right? Smaller than 0.05, smaller than 0.01, right? So in those two scenarios, we would say there's a significant difference. What would you say if you had set the significance level at 0.001? What would you guys conclude in that case? Anyone want to take a guess? What is okay? Then you just ask, what is bigger, 0.001 or 0.0029?
0.0029 is bigger.
Right. So that is bigger, right? Probably than our probability threshold. So what would you conclude, Lauren?
Oh, I'm on mute. Sorry. Oh gosh. Now I'm on the spot and I'm nervous. I don't know.
Okay. I didn't mean to make you nervous.
So if 0.0029 is bigger than the significance level of 0.001, then it's, I don't know. You were tying the null.
So let's go through this, right? It's the same thing again as we did with the t-test, right? T-values. And maybe if we pull up a visual, maybe that will help. Let's pull up a visual. Let's see. But thank you for putting yourself out there, Lauren. Right here, and then I'm gonna coach you now to give us this response, okay? And maybe you'll get some backup, right? Here we said we have this F curve, which it looks like weird like that, but it's only positive because it's a ratio, right? It's always, it can go, one means the ratios are the same, right? Between is about the same as within. Remember we said 10 divided by 10 is 1, or 5 divided by 5 is 1, right? And now we had 7, so 7 will be way over here in that case, right? But let's say the 5% level is here. Well, let's actually, in this case, it's the 5% level. Let's say it will be the 1% level is right here. Or let's say if the 0.01% level is right here, the 0.0029 level will be just on the other side, right? It will be just over here. So that 0.001 is like that line in the sand where you say, okay, as soon as it's in this gray area, we will reject the null. If it's still in the white area, we will retain the null. So it's still the same principle here. But now what we do is we just know there is a difference or there's not a difference. We don't know exactly, we don't know yet where exactly that difference would be. What did you guys think?
When you ask what do we think, are you asking what do we think about the question you asked Lauren previously, or what do we think about the whole concept?
No, yeah, sorry. Yeah, what do you think about the whole concept now? I mean, does that, do you understand better where that F value comes from, how it relates to the between or within, or is it still a bit confusing? I can repeat it one more time and you can, I don't want to bore you guys, but if you want me to say that one more time, I can.
I think for me, it's just a practice thing. Everything that I've done, I like spread out, and I have my, book, and I have my slides and everything. So I'm always kind of comparing back and forth through all the resources.
Uh-huh.
So I just know for myself, I'm visual, and I'm sure after the second module of kind of the same topic, it's going to be much easier. I think we had less practice opportunity in the previous module versus the other modules we had, just because, I don't know, maybe there's not as much posted, but I think I like the practice of lots of options because when it comes to the assessment, the prompt is different than every other prompt that you've had before. So the more practice, the better in my eyes.
Okay. What do you mean by the prompt is different?
I guess like the topic of information that you're comparing. So you kind of have to read through all of the different sentences with the paragraphs describing the type of data that we're going to be looking at, and I go through and like highlight the important stuff.
Oh, okay.
You know, so the more practice I have with different types of prompts in order to kind of search for the data that we are going to be using to complete the assignment, the better, because you're just challenging yourself with the variety of prompts and issues. Yeah.
Yes, exactly.
Actually, I really liked the article.
Did you?
Yes. I'm in the HEAL program, and some of the material that we're reading has, experiments or interviews, and then they kind of analyze the data. So it's kind of nice that everything finally is lining up together. Like it feels like, okay, this makes sense now. It was, I think, but previously it was a lot of definitions, a kind of memorization of words, and now I feel like it's all kind of going together. So the article was really cool. Thank you for doing that.
Okay, great. Well, I'm glad to hear that. So there's going to be another one next week. And that's the goal too, that you could calculate yourself, and you will, but also that you can be more a critical consumer of our research articles, right? So I'm glad that you noticed that. Here briefly, I want to show you guys just one more time, highlight the overall logic. That first, right, you again formulate your hypothesis, and then basically the question is there a difference between the groups, right? And what we do is we calculate the variance between groups, the variance within groups. We compare those two with each other and calculate that F ratio, right? We basically ask, where is the variation bigger, between the groups or within each group? So we get that F ratio, and in our example here was 7, right? And now we figure out what's the probability of us getting a 7, right? In the ancient times, we used to look this up in tables to get a probability estimate. Now we can just use a computer, and that gives us the exact p-value, right? It's basically the same goal. It's a little bit different way of getting there. And then we use the same logic that you guys always used before already with the t-test and the p-values. We just ask, is our p-value that we calculated, is that bigger or smaller than the significance level that we defined in the beginning? Right? That's why it's so important to say, hey, we're going to test at the 5% level, or we're going to test at the 1% level, or at the 0.01%, 0.01% level, because we might have a p-value of 0.03, right? 0.03 is exactly between 0.05 and 0.01, right? So if you had a 5% level, significance level, you would say, oh, this is statistically significant. But if you had a 0.01% level, you would think, oh no, that's not significant. I want to be sure. I want to be very sure that this is not just a random occurrence. Yes, and then once you're there, then you calculate the differences between the groups, and for that purpose, then you go into the post-hoc comparisons. So that folder is important as well. And if your Anova tells you there is no significant difference between those groups, then you're done. You don't even have to go look at the different groups. So here you have the description of the different post hoc tests. All right, any other questions or comments? So you will see now this week it's going to be a two-way ANOVA, basically the same thing. I'm going to spend a little time talking about that. Basically same idea, but now we add another factor, right? For example, if you had 4 sections, now we're also going to look at boys and girls, right? So now you have you have a variable that's called the sections. You have also a variable called the girls and the gender. You might have a question. Well, depending on the learning method, do boys do better than girls, or do girls do better than boys? Right. So now you can talk about testing 2 variables at the same time. And what happens is also we get interaction effects. That's what's really important. And that's where the 2NO is really strong, is to test the interaction between 2 different variables. And for that, I won't talk too much about it, but if you have questions, if you don't get started, you can then ask on Thursday again. But there's a lot of explanations of, okay, how do we take that next level? And I think once you get through module 7, it's kind of what Lauren was referring to earlier. I think once you get through module 7, a lot of the module 6 should be clarifying, because it's going to repeat that over again. So it's just making it a little bit more complicated. Okay, any other questions or comments? So the module 7 is available, and in case you haven't seen it yet, you can get started. And that one is really useful. From my experience, well, all of what we do is useful, but that one is really particularly interesting, because you can, a lot of times we don't always ask these questions, but what is better? Is it, for example, teaching method A better than teaching method B? Well, it depends, right? And if the answer is something like it depends, a 2-way ANOVA is really the way to go. Or at least a way to find out if it does depend on it. All right, on that note, I wish you a great week. As always, if there are questions in between, let us know on the discussion board, or also if you want to schedule meetings on Zoom, or if you want to stop by the office, feel free to drop in. Just let me know and we can schedule something.
Okay, well, thank you.
Thank you.
Yeah, you're welcome. Have a good evening. Have a great week.
You too.
You too.
You do as well.
Thank you. Bye-bye.